But just before it loads up, I'll let you know this project is part of a consortium that is funded by Crown Estate Scotland, and the work it's under the project Salmon Parasite Interactions in Linnhe, Lorne and Shuina, or SPILLS for short, which John mentioned earlier. So thank you for the introduction, Karin. I really appreciate that. And yeah, the solution I'm going to talk about today is looking at how we can reduce uncertainty in sea lice dispersal models. So hydrodynamic ocean circulation models coupled with Langerian particle tracking models are really super valuable tools for our coastal ecology and management. They help us to identify connectivity between finfish farms. So John mentioned that earlier in his talk. They're really important for looking at aquaculture management areas. They can be used to further our understanding of potential risk that's associated with human activities. They're really important for looking at salmon migration pathways, and of course they're really useful for sea lice dispersal models. But most studies only use one model, and generally they don't provide much in terms of a metric of uncertainty. So uncertainty can be thought of as the variability between the model output and the absolute truth in the conditions of the real world. There are different sources of uncertainty that we're super interested in when we consider sea lice dispersal models. So first we've got noisiness in we've got noisiness in the observational data, and we've got imprecision in the model structure and the parameter values associated with that. When we combine the data and the model uncertainty, then we have more variability in our model predictions. So uncertainty measures are metrics for the purpose of human understanding. So they don't actually help us in terms of model performance, but they're really useful for gauging how much we can trust our model. So as part of the SPILLS project, we're investigating if we can use an ensemble approach to help us explain the level of uncertainty in the individual models, and then also to help reduce the misfit between the validation data that we've collected in the field and the individual model runs. So here we're using three different, we're applying a suite of 3 different particle tracking models, and we're using the same underlying hydrodynamic model. And what we're doing is we're going to test what we're testing is the variability, how much variability can we assess and predict in our models using an ensemble approach. So the schematic I've shown here shows just basically what we've done in terms of the conceptual idea between in producing an ensemble approach. So our study takes 3 particle tracking applications from 3 different sectors. So we've got an academic model, a government model, and an industry model. And what we've done is we've coupled them with the same wider Loch Linnhe shelf hydrodynamic model. And what we're doing is we're testing the variability between our particle tracking models, and we're looking to see how much uncertainty we can trying to understand how much uncertainty will arise in the individual models. So we will see differences in things like the initial conditions, the varying parameter values, and then obviously the structural differences in the models. So each model uses the same lice counts from the farms as source data, and each considers a suite of different biological parameters of relevance to sea lice. And each then is individually validated using data collected in the field. So here on the screen now, I've put up some maps showing the predicted sea lice density from our 3 individual models for a snapshot during our study period. And the plots on the left show, the plots next to the maps show the fit with some sentinel cage data for the same temporal snapshot. So then these are all combined into a mean weighted ensemble, and the ensemble then is compared with the field data as well. And what we can see here is the industry model at the bottom is giving a better fit with the data than the other 2 models. And we've got, this is hot off the press, by the way, so this ensemble approach was pulled together on Friday. So we're still investigating why the models are fitting differently and looking at the underlying parameter values. So, paper to follow in the coming months. So I was given a 5-minute slot, so by way of conclusion, I'm going to just ask you to take away the point that no one model is ever going to be capable of representing the absolute truth in a system. It's really important to highlight to our end users that the appropriate use of any model is as a tool from which we extract information, and these aren't competing attempts of reality. So in Scotland, we're currently developing a new management system, and obviously the TLS in Norway. These management systems can benefit from an assessment of uncertainty because it's important for experts to be given the information that they can use. So a model it can't contextualize the circumstances the same as a human expert might. But by giving an expert the information on the uncertainty in the model, they can use that then to aid their appropriate decision making. So yeah, that's kind of what I've got in 5 minutes. Thanks a million. I'm going to go and sit down.